So, hi everyone, thanks for coming. My name is Zuzana and I work for ESET as a reverse engineer, which means I analyze malware on a daily basis. So I disassemble the code and then analyze the malicious code. And I'm trying to find out what's going on. This helps detection, but also I'm working on tracking some long-term malware campaigns. And also I'm a graduate of this faculty, so I'm glad to be here because this is the very lecture room when I first learned about security, about reverse engineering. So it's actually nice that the security track is here. And what I'm going to talk about today, well, this conference topic is the latest trends in emerging technologies and open source. And you are promised to learn quite a lot about both of these things. But just before we dive into it, into all of these interesting talks, and before we start using these exciting technologies, I'd like to take a moment and talk a little bit about security, about how to code not only with passion, but also with responsibility. So the reason I'm here is that, as you probably know, ESET is a security company. So what we deal with on a daily basis is a lot of malicious code. So we are trying to detect malware as much as possible. And we also work at improving our technologies to protect against these threats. But also we do a lot of malware research, and that's the reason I'm here. We are tracking cybercrime groups, cyber espionage groups. We also do IoT research and also penetration testing. And what we see often is how it works if the secure coding goes wrong. What happens if developers make mistakes, or they don't think about security, or they do but then don't do it perfectly. And we see a lot of examples from the real world what can happen if security is not put on the first place. So that brings me to today's agenda. I would like to talk a little about secure coding, but I'm not a programmer, and I'm sure each of you uses a different language, codes for different platform. So I'm not really going to tell you the golden rule set of what you should do and what you shouldn't do for your language, but this should be more of an explanatory talk or of guidelines, maybe some best practices, what you could do and why you should do it. And also, I'd like to make you think that why it's so important that you should care about whether your code is secure or not. So this is for the ones who don't have much experience with security, but also I think some of you already do have this experience. So for those of you, I believe that this example-driven talk can have a different aspect. Maybe sometimes you're trying to explain to your peers why they should code more securely, and maybe you struggle finding examples. So maybe today you will find some good arguments or good examples on why you should code securely. So we're going to talk about 5 topics. Each will be covering a different part of the development lifecycle. And I will use a lot of examples, and sometimes I'll provide QR codes to some interesting articles. So if you have a QR code reader on your mobile phone, just feel free to prepare it. Maybe sometimes you'll use it. So let's start with the first part, and that's just the basics, why security is important at all. And you probably know this, but since the topic of this conference is part emerging technologies, I'd like to look at the technologies that were once emerging, but no one really cared about security, and let's see how it worked out. So the first of them, modems, GSM modems, you use these devices and you know how to control them. But sometimes, like 40 years ago, there was this protocol developed, AT command set or Hayes command protocol, and this protocol was used to control GSM modems and other devices. So you would connect your modem to a computer, and then you would use these commands to control this modem to set up connection settings or to dial up. And also later, these commands were extended, so not only it was used for modems, but also other devices for different specific vendors, and there are thousands of AT commands now. And the reason I'm talking about it is this paper, which was published a year ago. And this paper found out that not only these AT commands are still used in modern smartphones, so also maybe your smartphones support these commands, but they're very poorly secured, and it can pose a security risk if you connect your smartphone to a computer. Then just by using these AT commands, you're able to do things such as rewrite device firmware, or inject touch events, or exfiltrate some sensitive data such as SMS messages. And this is just a theory, but this year it was actually discovered that this is what malware is actually doing. It is using these ancient AT commands for GSM fingerprinting of connected devices to your computer. And how it works is that if the computer has some device connected, then the malware can detect it and start sending AT commands to learn things like the device manufacturer, software version, but also IMEI number, which is the unique device ID, or IMSI number, that's the ID of the device owner, the owner of the SIM card, or MSI SDN number, and that's the mapping between the owner identity and telephone number. And that's not all. This was used only for device fingerprinting, but as I said, there are many thousands AT commands out there, and these are vendor specific. So what we learned from this case is that after the attackers can learn about what kind of device is connected to the computer, then they can deploy more customized plugin with these vendor-specific commands, and then they can do all sorts of things, data theft, device firmware is rewritten, etc. So what we can learn from this case is that even if these commands were engineered years ago and with no regard of security, they are still used today, and they can be misused. Even you have devices that support these kind of commands, and there is no security countermeasure to prevent misusing them. And this is just one case, but there are also more severe cases. For example, take Industroyer. That's the malware that was responsible for a power outage in Ukraine some years ago. These cases happened before, but this one is unique because the malware was actually able to speak directly to devices that controlled electricity circuits and circuit switches. So it was actually able to turn off electricity for part of Kiev, the capital of Ukraine. And how it worked was that it infiltrated the power grid, the network, and then at one moment, it just stopped electricity for the whole part of the town. And the reason it worked was because this malware was able to speak these ancient industrial command protocols. Again, these were designed with no security in mind, so the malware didn't actually have to exploit any vulnerabilities. It just had to learn how to speak these languages. And in this case, it had really severe consequences. The part of infrastructure, I mean, this is really interesting that these protocols are still in use today and are not secure at all. So again, we can see that the report says that only if you get access to these devices and you can send commands, then the game is over because there is no security at all. So again, what we can learn from this is that security should be considered as early as in the design phase. And maybe if you control some device with commands, you should think about what can go wrong if these commands are misused. What are capabilities of this device? In this case, it can control the electricity for the town. So it's not something like it's just a computer and you can play games there. It's a part of critical infrastructure. So when you're designing protocols for such devices, you should think more carefully about what it can do if it gets wrong. Okay, so that's just the beginning. I'm sure you all know by now. You all learned in school that they taught in school that you should think about security. And these are all ancient protocols, ancient devices, right? So maybe let's look at some technologies that are emerging now and that are new now, such as IoTs. I'm sure you also heard about this, that some IoTs are designed securely, some less so, and these are all kinds of devices like smartwatches, smart cameras, smart refrigerators. And the thing is that we are doing a lot of IoT research in ESET, and we still see that even the modern devices have all these security holes, and again, it's a problem. And even though they're trying to design the devices securely, there is some effort, it still goes wrong. So let's look at two cases. The first is this D-Link smart camera. So it's that kind of device that you used for recording audio stream in your home, maybe to be able to monitor if there are any thieves or so. And sometimes this camera, you can connect to it via internet and you can follow the stream online. So all good there, but there are some problems. In this case, the vulnerabilities in this camera allow the attackers to tap into the video stream online and be able to listen to it. And the reason is that, okay, so you have this camera right on the right side, and then this camera communicates with the cloud where it uploads the stream of video that is recorded. And then for you to be able to listen or look at the recording, you have to connect to the cloud. And the thing is that not the whole communication between the cloud and the client and the cloud and the camera was encrypted. So the part was encrypted, but part was not. It was transmitted in a TCP tunnel using a custom D-Link tunneling protocol, and not all the data inside were encrypted. So it was possible to conduct a man-in-the-middle attack on both parts of the connection and then intercept the stream that was recorded. And what was the problem here is the way how the access to the stream was checked. So remember that there was a custom tunnel used for transmitting the communication, but the tunnel was not protected. So anyone who was inside the network, anyone who had the IP address of localhost could connect to the tunnel and would be allowed access. And what's worse is that the access would have admin privileges just like this. So if you are in the network, for example, if you deploy malware on any machines which are in the network, you could easily have access to the camera. And that's not all. So you have access to the camera, you can listen to the video stream, but also when we looked at how the device updates itself, we learned that it doesn't check the authenticity or integrity of the firmware updates. So not only you could use this tunnel access to look at the video stream, but you could also push some firmware updates with some malware or whatever you want. So this was the case of the D-Link camera. Now parts of the vulnerabilities are of course patched and the updated firmware is pushed to the clients. But again, we could learn some things from this. The first thing, you should always encrypt your communication. It doesn't matter whether it's from the server to the application or to the device or between themselves. If it transmits such crucial data such as the video stream, which you can see a lot of interesting things there, then you should always encrypt these. Also, you should control access to whoever is able to access these streams or this communication or able to send commands. And also, whenever you are pushing updates, it doesn't matter if it's software updates or firmware updates, they should be digitally signed, and you should check these signatures. You shouldn't let your device run any code that gets pushed as an update, because this can be misused. And as we see, it happens. So it's really important that you think about it. Another case is this device, which is used for smart home controlling. You can connect your smart sockets, smart light bulbs, anything to this device, and it serves as a hub. And there were other vulnerabilities found, but again, they were very severe. So this device was vulnerable to man-in-the-middle attack and a command injection attack. I'm sure you've heard about this before. And as a result, it was possible to inject a backdoor to the device with administrative privileges. So what was the reason behind that? This time the communication was encrypted, so design is better than in the previous case. But again, there was some mistake. The device didn't check authenticity of the server certificate. So again, you could go into the communication and you could inject some commands. And how you could inject the commands? Okay, this is a part of a code. Let's just explain some important parts. This code is used for passing some parameters to the device. The port and IP address doesn't matter, but the problem here was that the input was not properly validated and escaped, And because these parameters are then used in the command below, then you could inject other commands and you could do whatever you want. So you could you could execute some other commands and deploy a backdoor then. But this is still with some normal privileges, but you could also push some additional privileges to the backdoor thanks to the fact that the device had a hard-coded root password inside. It was encrypted, but poor encryption method was used. So again, it could be brute force in like 3 hours or so. So not only you were able to inject a backdoor using command injection and man-in-the-middle attack, but also you were able to gain administrative privileges. So this was the case of the other device. And what we can learn from this, again, whenever you use crypto, you should use the latest crypto. You should use reputable crypto libraries. Don't do your own implementations. Don't think that you can be smarter than the other people who were already looking at how to implement cryptography. Also, you should verify the server certificates whenever you're trying to encrypt the communication. It's not enough if you encrypt it and then don't verify the authenticity. You should think about all the parts of the communication. So even if you have a good design, you should still be looking into how to implement it. And of course, don't use hard-coded passwords, even if you encrypt them, because they can be brute forced. And again, it can have severe consequences. So this was the 2 research pieces, but these are just academic research, right? So this doesn't happen in real life. Well, I think you all remember this botnet. So just to recap, the Mirai botnet was a botnet of IoT devices which used hard-coded passwords, and it was used to conduct DDoS attacks on some DNS providers, which had, again, severe results because a lot of people were without access to the internet thanks to the fact that they didn't have access to the DNS server. So this rings a bell, right? So if you are writing these kind of IoT devices and you want to do them very lightweight with no security, with no crypto, and you use some hard-coded passwords, some credentials for remote administration, again, you can not only pose a risk to your users, but also to the whole internet. Even if your users don't have consequences from this, then some other people on the other side of the world can have. And this is also something you should be concerned about, even if it's not your users that have harm. All right, so to the third part, now you all know that you should design your devices with security in mind, and then you should be careful how to implement those. But even though you implement them securely, or you're trying to do that, there is always some room for mistakes. You should be always prepared that you failed, because if you have a large code base, then there's also always some risk that there will be some vulnerabilities. And it happens a lot in all kinds of vendors, bigger software companies, smaller companies. And especially if you're contributing to an open source, then it's easier to find those vulnerabilities because the attackers have access to your source code. So again, let's look at some cases. This year, it was reported that WinRAR Packer had a vulnerability that resulted in code execution and installation of code if it was misused. So it was a path traversal vulnerability, and maybe I'll start with the video. Okay, you can see it. Just let me, okay. Okay, so how this works is that you receive a compressed package, and this package usually has a path when it should be extracted. So again, it is what happened this time. You have a package that has a hard-coded path, but because of a path traversal bug in the WinRAR, when you extract the package using a legitimate WinRAR, you can see it now, so you're extracting the package using WinRAR, then not only the file gets extracted over there on the left, so this is the innocent file on the intended path, but also another file gets extracted in a startup folder. And that shouldn't happen, because that's not what was intended to be done with this package. So the startup folder is interesting because it contains files that should be executed every time your PC is powered on. So what could happen here is that when the victim extracts this package, they will see all those innocent files, so it's how intended, so nothing fishy going on. But at the same time, there are some malicious files in the startup folder. So next time they will power on their computer, these files get executed, and the victim doesn't know anything. They didn't execute any malicious file. They just executed WinRAR, which is legitimate, and they trust them. So that's why it's so dangerous. And just briefly how it worked was that when WinRAR developers check for the path when when the file should be extracted, then they don't check it properly. These are all the blacklisted patterns there, but actually you can use a different pattern which is not in the blacklist, and then after the checks, it can result in this path. And what this means is when you have the package, for example, on the desktop, then by this you can go one folder up and then specify the path of the startup folder, and then you can drop the malicious file there. So it's as easy as this. And after this vulnerability was disclosed, there were a lot of different exploits out there. A lot of different malware campaigns were abusing this. The list goes on and on and on. And the thing is that even though WinRAR already patched this vulnerability in February this year, then there are still users that use the outdated WinRAR. How often does it happen to user that some update is offered, but the user doesn't care and doesn't update? So you should think about it. Not only you should think about how to code securely, but also you should think about what happens when ultimately there is some bug, there is some vulnerability found in your code, because it may happen. It happens to the biggest players. Also, the Windows has some security updates every month, every second Tuesday of every month. This is the list of updates pushed by Apple. These are security updates, and this is just from the previous date. So you can see it happens a lot. It happens to the biggest vendors out there, so it will happen to you ultimately. And what happens when you find a vulnerability? Do you have some process how to fix it? Do you have a process how to push a security update? Are you sure that your users will update the code? It has to be all thought about in advance so that you can be prepared for this kind of incidents. So that's the takeaway from here. Not only you should code securely, but also be prepared that you will ultimately fail. Okay, moving on. Now we all know that we should code securely and we should have some patch processes, but also you should think about all kinds of data that you collect. And it doesn't matter whether you code for Windows or Linux or iOS, for mobile platforms or for web services. Probably all of your applications collect some kind of data. Probably all of you have to store the data somewhere. And maybe it's time to think about how you store the data. It's a big topic nowadays with GDPR and all that stuff. But we all remember how it worked with LinkedIn in 2012, when a database was leaked with millions of passwords of the users. And the thing here is that the passwords were not in clear text, they were hashed. So maybe no one should be able to brute force them, but they only used hashes without salt, which is a really, really bad practice. So in few hours, most of the passwords were recovered. And this is a severe breach for the company, because not only the users' data get exposed and they are exposed to risk, but also it can hurt your reputation as a company if people find out that their data are not secure within your databases. So again, I've said this before, but whenever you use cryptography, use reputable libraries. Don't try to implement it yourself. Think about how you store the data. Think about how you secure it. Think about, what if the data gets leaked? Is it still protected, or are the passwords going to be exposed, just as in this case? And for the last part, once we know all of this, we still have to think about all the other components that we are interacting with. It's not just your code. It's not like you write all the project from the scratch. You use a lot of different libraries, external components, and once you have your code pushed to the clients, you often have to have security updates, software updates, all of these interacting components. And again, they have to interact in a secure way. And you have to make sure that you don't get misused by any of these components. It's not just the main part of the code that should be secure, but it's also all the other parts and their interaction. So let's just see a few examples, very different examples of how it can go wrong, and maybe look at how we can learn from that. So DLL hijacking is a technique that you may be familiar with, but just to recap, it's a technique that's used against Windows OS by malware when it wants to misuse some legitimate software to sideload a malicious library. So the reason for that is because some vendors of legitimate software don't specify the full path of the DLL library that gets loaded, a legitimate DLL library, and then some other library can get loaded instead. So how this works is that you have the legitimate app installed in the system folder with a legitimate DLL. And normally when you open the app or when you execute it, then this DLL gets loaded. But when the system of some user gets infiltrated, then in a different folder, there can be a malicious DLL. And what happens pretty often is that then there is a different folder, say some temporary files or something like that, and the malware copies both itself, the malicious DLL, and the legitimate executable file. And once the user executes the file, or the malware executes the file, then because the path of the DLL is not hard-coded in the executable, then the DLL search order is applied. And the first in the order is the folder from which the application is loaded. So it's not the folder, the system folder when the actual DLL is residing, but it's the folder from which the executable is executed. So what happens is that malware tries to execute the legitimate file. So you see this kind of prompt, which you're familiar with, and you see that some verified publisher, which you know, Adobe or Microsoft, is trying to access your hard drive or something like that. So you write your password, why wouldn't you? If you saw some unknown file or some unknown provider, maybe you wouldn't do that. But in this case, the malware can misuse the trust that you have towards this company. And then the malware gets executed instead of the original DLL file. And most of the cases, you won't even recognize that because the malicious DLL can also act like a proxy to the actual DLL, but at the same time, it can do something wrong, some malicious code can get executed. So this is what can go wrong, even if you do everything as you should, but you forget about specifying the full path to the DLL. You can get misused by some other malware that you've never heard about because the users don't secure their computers and they get some malware, and the malware doesn't care if it's your product or any other product. They're just scanning the system folder for all the applications that are out there and are trying to find whatever application can be misused. So this is how it works, and it gets exploited quite often. And another thing about libraries, not related to this, is what if you are using some other libraries and these libraries have vulnerabilities? Do you know about it? Do you have a process to update these libraries to the newest versions? Do you follow whether there are some security patches to, I don't know, OpenSSL library if it gets a bug? With these libraries and these external components, there are all kinds of problems that you need to think about. It's not just your code, but it's also some other parts of the cycle that can introduce security vulnerabilities. Another whole different attack is a supply chain attack. And again, let's look at some real example, which happened 2 years ago. So MEDoc is a software company that is taking care of some accounting software, mostly in Ukraine. And in 2017, they got hacked. And then subsequently, when they were pushing updates to their clients, these updates were Trojanized, so there was some malware included. And what happened then is that when this malware was executed as an update, it was the infamous NotPetya ransomware, the most devastating ransomware attack because it targeted governments and hospitals and large corporations. Ransomware is that malware that encrypts your data and then demands ransom for that. So some money needs to be paid. And if you have a large company, a lot of computers, and each of them is locked, then you can get in some trouble. But the reason I'm talking about it here is not the ransomware. Maybe you don't care. But the reason is that you have some trust of your consumers or customers or users, and this trust can easily get misused. Maybe you are not careful with your internal security, you get hacked. Well, that can happen, of course. But then again, you are pushing software to the clients, and they are trusting this software that it's legitimate, so they will just execute it no matter what. And it happened a lot. Not only this case, but it happens more often than you think, that like this, the trust of the company can be misused and then they can distribute malware. And it can also happen if the company is not leaked at all. FinSpy was another case of an application of a malware which was distributed by misusing trust of legitimate vendors. So how it worked was that some of the vendors, some of the software is distributed by websites. So you go to the website and download the software. And sometimes the website from which you download the software is not secured. It uses HTTP, not HTTPS. So what FinSpy was doing was, there was a man-in-the-middle attack between the end user and the website that was serving the legitimate software. And when the user tried to download the software, so when he clicked on the download link, then the legitimate app was switched to the legitimate app, which was trojanized by some malware. And this actually happened with a lot of different software. So some of the legitimate websites were hacked this way, but not really hacked, and also some not official website. But the thing here is that there are a lot of places when between the end user and the website when there can be a man-in-the-middle attack. So you can have your cable tapped, or it can be the ISP provider that is using these kind of attacks. It can be happening on a lot of different places, so you never know. For example, think about hotel Wi-Fi, think about some unsecured cable. Someone can be interested into intercepting. Maybe it's not a mass spreading malware like this. Maybe this is used only for some targeted campaigns against some interesting targets. So it's not like a lot of your users would be infected. But again, just by not using HTTP in your communication for distributing your software, you can leave the door open to these kind of malware actors. And just when the user is trying to download the software that he trusts, your software, it can get wrong and malicious software can get downloaded as well. So what we can learn from this is, again, don't use HTTP. Always secure your communication. Always check whether the code that you downloaded is actually the code that you intended. So you should use digital signatures. So when the malicious actor would try to switch your software for a trojanized version, there wouldn't be the digital signature. So maybe the users would get suspicious. And that brings me to a conclusion. So we have seen a lot of different examples, a lot of different platforms, and it didn't really have anything to do with itself, but we can extract some interesting knowledge or some guidelines from this. So first of all is the question why you should care about security. I think you all know by now it's not just about your users that you are protecting, but it's also your reputation. You as a developer have some trust of your users, and if this trust gets misused, if data gets leaked, or if you are hacked and you distribute malware, then maybe they will choose someone else. And of course, by adopting secure coding, you can also protect the world. Remember the Mirai botnet when the vendors of IoT devices didn't have any harm, but they were harming the rest of the world just by making some mistakes. And the other question is what you should then do if these are all the things that you shouldn't do. So let's talk about some. First of all, whenever you code something, whenever you write some code or you design some device, think about security. It's better to be done from the beginning than ad hoc when all the code is written. But of course, after you write the code, make sure it's really secure. So do some internal testing or some external penetration tests, or some big companies have bug bounties for people who find vulnerabilities. It also can work that way. The only thing is that you have to think about it in advance, but also be prepared that all these measures can fail and there can be ultimately some vulnerability reported. So you should have some mechanisms how to patch those vulnerabilities and how to push them to the clients. And then of course use these mechanisms on a timely basis whenever you learn about vulnerability. If you use different other components, such as libraries, then you should also be monitoring whether these libraries are up to date and whether they don't have any security problems. If you store any data, which you probably are, then store the data securely and use reputable cryptographic libraries to do so. If you use a lot of different components, which you probably do, you probably have updates, software updates, firmware updates, some other libraries, then make sure to sign those components and then, of course, to check their integrity, because it's not the solution to just sign it, but also you should check it. We have seen that in the IoT research that sometimes only part of this solution happens and that's not the win. Also, whenever your components are communicating with each other, this communication should be encrypted, otherwise someone else can get in. And as a final thought, you should also try to learn more about security. You should learn more about the language that you're writing in, because I'm not an expert in your languages, but you should be. You should know what are the security risks of your language, of your platform, of the devices that you are coding for. And you should also not be shy to talk about these security issues with other people on forums or to reach out to security experts. Thank you for your attention. We have 2 minutes, so if you have any questions, I'll be happy to answer them. Or maybe after this talk, you can talk to me in a break. So are there any questions? First one.
Please, if you have any questions, I will give you a microphone.
Okay, thank you. So what changes do you expect after the quantum computing regarding the vulnerability of the crypto libraries?
Okay, this is not up to me, and it's not up to you to think about that, but you should be aware of this. You should be aware that there might be some change, so maybe some crypto which is considered secure now, will not be considered secure later. So this is the last tip, right? You should educate yourself, so you should follow what's new, what are the new vulnerabilities out there. I'm not here to tell you you should do this and that. There's no one rule set. So I'm just trying to tell you to maybe have this right mindset, to follow the trends, to think about security, to have penetration testing. Maybe you don't know what this cryptography is, but maybe some other people will, and when they test your code, they will tell you that you are using an obsolete library, which is now deemed insecure, so you should change to this library. Okay, so if there are no other questions, then thank you for your attention.